Hi and welcome to the IB Economist tutorial on the linear demand function. This lesson is primarily designed for IB economic students who take the subject at higher level but might be of some use to A-level students or also to first-year college undergraduate students who study the subject of economics. My name is Peter and I would like to welcome you to this lesson. Let's have a look at the contents for this lesson. First, we will begin by looking at the formula for the linear demand function. Then we will learn how to plot the demand curve using the same formula. Then we will look at the values for the q-intercept, which is the horizontal intercept, or the point where the function intersects with the horizontal axis, and the slope of the curve. We'll then learn how to obtain the demand function from a set of given points. Finally, we would see what would happen to the demand curve when we change the values of a, which is the intercept, and of negative b, which is the slope of the curve. We begin by looking at the formula for the linear demand function. The formula is given by this equation. QD is equal to a minus BP. QD is the quantity demanded for the good. P is the price of the good. A and negative b are constant values. We'll look in a bit about the meaning of these two constants. Let's have a look at a practical example. Imagine that we are given a demand function with the following equation. QD is equal to 20 minus 5p. Now, in order to sketch this function, we need to find corresponding values for the quantity demanded and for the price. So let's calculate the corresponding values for quantity demanded if we have prices from 0 to 4. These are the calculated values. We see that if the price is equal to 0, then the quantity demanded would be equal to 20. If the price is equal to 1, the quantity demanded would equal to 15. If the price is equal to 2, quantity demanded becomes 10, and so on. Now, if we want to sketch it, we need to generate a diagram with proper axes and proper labels. Okay, so our diagram would have a price on the vertical axis and quantity per week on the horizontal axis. Note that we have chosen such values so that we can plot all our points that we have available. So plotting the points is relatively straightforward, and the demand function would be the line that goes through all the points. It's this green line which we have labeled D. So that's it. It's quite simple. When you're given a demand equation, all you have to do is actually calculate the corresponding price and quantity demanded for only 2 points. If it's a straight line, then all the remaining points would still lie on the demand curve. So all you have to do is just choose 2 values for the price, plug them in the equation, find the corresponding values for the quantity demanded, connect them with a line, and this is your demand curve. Next, we are going to look at the q-intercept and the slope of the demand curve. The constant a in our equation represents the point where the demand curve intersects the horizontal axis. This is the quantity axis. We can call this the q-intercept. Then we have the slope of the demand curve. This is given to us by the constant negative b. In order to calculate the slope of the curve, we need to have 2 points which lie on the demand curve. When we have these 2 points, we can use this equation. Negative b would equal to q2 minus q1 divided by p2 minus p1, where the coordinates of the first point would be q1 and p1, and the coordinates of the second point would be p2 and q2. Then we can calculate the q-intercept by simply plugging in one of the points in the equation, plugging in the value of negative b, and solving for a. We can also calculate what is known as the p-intercept, which would be equal to the value of a divided by b. Let's have a look at an application of the formulas that we just saw. On the screen, you can see that we have a demand curve with the equation QD is equal to A minus BP. We have 2 points lying on this demand curve. Point x with coordinates px and qx, and point y with the coordinates py and qy. Now, this is all the information that we need in order to be able to derive the equations for negative b, which is the slope, and for a, which is the quantity intercept. So negative b would equal to qy minus qx divided by py minus px. A would equal to qx plus bpx, or qy plus bpy. Essentially what we are doing here is we are plotting in one of the 2 points in our demand equation. We know the value of negative b and we are just solving for a. And using this information we then can find the p-intercept, and we can see the coordinates for our 2 intercepts. Z represents the q-intercept, and we can see that its coordinates are a and 0. W represents the p-intercept, and we can see that its coordinates are 0 and a divided by b. In the following example, we are actually going to apply numerical values, and we'll find the true value of negative b and a. So we are just given an equation, qd is equal to a minus bp. However, we have 4 points which lie on this demand curve. For the price of 20, our quantity demanded is equal to 30. For the price of 15, our quantity demanded is equal to 40. For the price of 10, our quantity demanded is equal to 50. And for the price of 5, our quantity demanded is equal to 60. Now, we actually need only 2 points in order to calculate negative b and a. So we are going to use the first 2 points with price 20 and quantity demanded 30, and point B with price 15 and quantity demanded 40. So we can derive our Q1, P1, Q2 and P2 from these 2 points. Essentially, you can use any 2 points that lie on the demand curve. For this example, we just picked the first 2. Now that we actually know the values of Q1, Q2, P1 and P2, we can plot them in our equations, and we can calculate the value of negative b. So negative b would equal to 40 minus 30 divided by 15 minus 20, which is equal to 10 divided by negative 5, or negative b would equal to negative 2. Now that we know the value of negative b, we can plot it in our original demand equation, plot in also one of the points that we are given, and we'll be able to find the value of a. In this case, we are using our first point with price 20 and quantity demanded 30, and we get that 30 is equal to a minus 2 times 20. Essentially, 30 would equal to a minus 40, or a would be equal to 30 plus 40, which is 70. Now that we know the values of negative b and a, we can actually derive the formula for our demand curve. d1 is given by qd equal to 70 minus 2p. This is the equation of our demand curve. The actions that we just performed can be summarized in 3 steps. Number 1, if we want to be able to solve for the demand equation, we must have at least 2 points which lie on the demand curve. Then we can obtain the slope from these 2 points. Once we have the slope, we can substitute in the demand equation one of the points and the slope, and we can solve for the q-intercept. This is our a value. Next, we'll look what will happen if we change the value of the intercept of an equation. You can see that we have 2 demand equations. The first one is given by the formula qd is equal to 70 minus 2p, and the second one has the equation qd2 is equal to 50 minus 2p. We can notice that the slope of the 2 equations is identical. It's negative 2. However, the q-intercept is 70 for the first demand equation and 50 for the second. Let's solve this. The first thing that we need to do in order to draw these 2 demand curves is to obtain 2 points for each of them. So if we set a price equal to 10, QD would equal to 70 minus 2 times 10, which is 70 minus 20, and it would generate a price of 50. And for QD2, 50 minus 20 would equal to 30. If we set a price equal to 20, quantity demanded 1 would equal to 70 minus 40, which is 30, and quantity demanded 2 would equal to 50 minus 40, which is 10. We can summarize this information in a table. So the first table gives us points W and X, which are part of the first demand curve, and the second table gives us points Y and Z, which belong to the second demand curve. Now we can plot these points on the graph. And remember, point X and point W are part of D1, and point Z and point Y belong to D2. So all we have to do in order to obtain the two demand curves is just draw them as they pass through their corresponding points. These are our two demand curves, D1 and D2. What do you notice about them? They are parallel. This is what happens when you change the intercept of a demand curve. When you change the intercept of a demand curve, you would shift it either to the left or to the right. So decreasing the value of the q-intercept A will shift the demand curve to the left, and increasing the value of the q-intercept A would shift the demand curve to the right. If you want to recap that, we can revise the following rules. Changing the value of A would shift the demand curve. If we increase A, then we will shift the curve to the right. Decreasing A will shift the curve to the left. Next, let's see what happens when we change the value of the slope. In this example, our intercepts are identical. They are 70, but we are going to have different slopes. So the first demand curve is given by the equation QD1 is equal to 70 minus 2p. The second demand curve, D3, is given by the equation QD3 is equal to 70 minus 4p. Again, note that the two slopes are different. The first one has a slope of -2, and D3 has a slope of -4. So in order to draw these two demand curves, again we're going to follow the same procedures. First we are going to obtain 2 points, and we'll just select prices of 10 and 15, and we get the corresponding values for QD1 and QD3. And we can summarize this in a table. So for the first demand function, when the price is equal to 10, the quantity demand would be equal to 50. This is our point W. And when the price is equal to 15, the quantity demanded would equal to 40. This is our point X. For the second demand curve, when the price is equal to 10, the quantity demand would equal to 30. This is our point Y. And when the price is equal to 15, the quantity demanded would equal to 10. This is our point Z. Again, we're going to plot these 4 points, and connecting X and W would give us the demand curve D1. Connecting Z and Y would give us the demand curve D3. We can see that this time the curve is actually rotating, and when we change the slope of the curve will be rotating around the q-intercept. Increasing the value of the slope, -b, which actually means that the value of b is decreasing, will rotate the demand curve clockwise around the q-intercept. As a result, the demand curve will become steeper. We can see this transition going from D3 to D1. We are increasing the value of -b. -4 is smaller than -2. So as we increase the value of -b, the curve rotates clockwise and becomes steeper. Definitely D1 is much steeper than D3. Decreasing the value of the slope -b, which in this case increases the value of b, will rotate the demand curve counterclockwise around the q-intercept. As a result, the demand curve will become flatter. And again, we can see this as the transition from D1 to D3. The slope of D1 is -2. the slope of D3 is negative 4. So the slope of D3 is actually smaller than the slope of D1. And as a result, the demand curve becomes flatter. We can revise what we just saw with the following three rules. Changing the value of negative B would rotate the demand curve around point A. Increasing the value of B would decrease the value of negative B and will make the curve flatter. Similarly, decreasing the value of B will increase the value of negative B, and this would make the curve steeper. Now, some of you which might be more mathematically oriented might find these changes in the slope confusing, and there is an explanation for that. In math, the slope behaves the opposite way than in economics. The reason why this happens is the way we place our dependent and independent variables on the graph. In economics, the axes of the dependent and independent variables are swapped when compared to mathematics. In mathematics, the independent variable x is on the horizontal axis and the dependent variable y is on the vertical axis, while in economics, our independent variable p is on the vertical axis and our dependent variable q is on the horizontal axis. This change was originally made by the economist Alfred Marshall when he was deriving mathematical equations with which to represent demand, supply, and overall changes in the market. If, however, you're not so mathematically oriented and you didn't spot this difference in the dependent and independent variables and their placement on the axis, then don't worry too much about it. Just follow the basic steps that we have provided. When you see the demand equation, first solve for the slope negative b by using the 2 points and their coordinates, then obtain the value of the intercept and you'll be fine. For those of you that spotted the difference, just be aware that in economics we have swapped the dependent and independent variables on the axis. I hope that you found this lesson to be useful, and feel free to come back for more information on the IB Economist channel on YouTube. Thank you. Bye bye.